lecturer in your PE department here, such as it is. And so this is week 2 of the academic training program, which is built for the foundation, academic foundation group, who we've yet to meet, but I'm sure they'll turn up at some point. Let me see if I can make this bigger. Okay, there we go. Fine, so this is week 2. So the first week we talked about what we're going to try and cover over the whole program, and we spent a bit of time talking about definitions of research, and really what the word that keeps coming out when you talk about research is trying to find out the best of this, the best of that. So we spent a bit of time talking about, well, what does that actually mean? You know, what when we say we want the best treatment for this, best treatment for that, you know, what does best mean? Is it best for a particular group? Is it best overall? You know, how do you determine what's best? How do you measure what's best, and so on? And we really came down to the idea that you're trying to work out the optimal treatment relative to everything else for a distinct group of people for a distinct kind of condition, if you like. And that's really as far as you can get in kind of 40 minutes talking about it. So these are the learning objectives for the whole program, and really we're going to try and cover everything that I certainly wished I'd have known when I signed on the dotted line to be a researcher, and you're sort of left to kind of find your own way through it. And so today what we're going to do is work on the next one down, which is formulating a research question, which to my mind is absolutely the key to the whole enterprise. So this is the bit that should almost take the longest of the whole project, really, is working out what question you want to answer and why, and all those sorts of things. Collecting the data and analysing it is almost the, well, it's not almost, it is the easier bit. So we're going to spend some time talking about the question and where research begins, really. How do you get a good idea? Because we all say, oh yeah, I'll do some research, or certainly people come to me and say, I want to do some research, and that doesn't mean anything. It's like saying, I want to do medicine, or I want to do therapy. It doesn't mean anything at all. So what actually do you mean? What you mean is, I've got some questions and I want to find the answer to, ideally. But I'm sure you've all had people turn out and say, well, I don't know what I want to know. I just know I want to do research because it looks good on my CV. And so that's how I started. We'll talk a bit about developing the research question, and I'm sure you've all had your own experiences of reaching a research question and deciding what you want to know and what you want to discover. So I'm interested to hear those. And then we'll talk a bit about the Pico brackets T structure. The T, I think, is a North American thing. So where do you get research ideas? Well, the first thing, so I've tried to construct the slides as my brain is working on them. So I've tried to keep them as casual as possible, really, to really reflect the reality of how I found my research going to be. And the first thing I realized is actually nobody knows anything at all in medicine. It's all about risks and uncertainties, isn't it? And research is about trying to understand those uncertainties, and in some cases risks. So no one knows anything for sure. You know, everybody 100 years ago knew that amputation was the right thing to do. At the minute, we know hip replacement is the right thing to do, or we know physiotherapy is the right thing to do. Actually, we don't know shit at all. Okay, we just know that that's probably the least bad that we're familiar with at the moment. So as soon as you get used to that, or as soon as I got used to that idea, so my MD was about air ambulances. Everybody knew they were a good thing. As soon as I got used to the idea that, well, actually nobody knows whether they're a good thing or not, suddenly the whole world of research opened up to me. So I thought, well, everything's up for grabs here. And so that's the first thing I thought when I started writing these slides, is no one knows anything at all. And then I thought, well, where have the work I have done to date, where has that come from? And I thought, well, actually, any time two people are having differences of opinions about anything at all in healthcare, there's a research study there of some form. You know, oh, they need an MR, they need a CT. There's a study. One of them is better, right? We just don't know which one. Or they need an uncemented hip, and they need a cemented one, or they need decompression, or they need decompression infusion, or they need therapy, anything at all. So every time you're in a clinical setting and two people have, or more than two people have, a difference of opinion as to what's best for that particular patient, there's a research study there. And in fact, you go deep enough, there's a whole career's worth of questions and PhDs and all sorts going on there. So that's where my long list of research studies comes from. It's listening in trauma meetings, listening in MDTs, listening in clinics, going to conferences, hearing the debates, and I just go, well, actually for, you know, Mabel, who's 90 with a broken hip, is it best to do this or that? No one knows. So then I thought, well, when else have I come up with projects? I thought, well, when I can't find the answer to something. So I find the hardest questions in medicine are the simplest ones. So someone will always tell you whether this implant or that implant is better. But actually, some of the simplest things, should you put a tourniquet on the leg or not? And nowhere in the books tells you, nowhere in the papers tells you, and so on. So maybe there's an unanswered question there that either people have been hiding from or haven't thought about before. And if you think about it, even, I mean, that goes right through everything, doesn't it? We didn't know we needed iPhones until they were invented, because no one thought, I need an iPhone. You know what I mean? So if no one's thought of the question at all, maybe there's some research, maybe there's a question to answer there. And then I thought, well, it goes even further then, because what if the answers are vague? So if people do like I did, no, just kind of do it. And that's just what we always do. And no one can say, this is why we do it, because here's the evidence to support that. Well, then there's a research question there. We've just functioning on assumed knowledge. You know, no one's ever going to do a trial comparing hip replacement versus not for advanced arthritis. You know, we just go, well, it must be better, right? Or maybe those trials were done donkeys ago. But if the answers are vague, then no one knows the answer, so there's a study there, easy peasy. And questions are absolutely everywhere in health, and I find that really difficult to understand. So people always said to me, oh, you question everything, question everything. You can't question everything, can you? Otherwise you spend all day going, but why, but why, but why, but why? It's meaningless, right? So, you know, but there are questions everywhere, but you have to find that one that makes you go, actually, you know what, I'm interested. That sounds like a cool thing to look into. Okay, spines is interesting because we know absolutely nothing and we make it up every day. Right? There's no good evidence whatsoever. And that's why spines is great, because there's questions absolutely everywhere, whatever you're into. So no one actually knows anything at all. And as soon as you make peace with that, research is the easiest career choice in health. So what about creating your specific ideas that you want to get into? Okay, so the first obvious one is something you're really interested in. Okay, so if you go, well, I love the spines. I like it because it's high risk and I can paralyze someone really easily. I think that's just gives me a rush to know that power's in my hands, right? So it's interesting, those sorts of things. Okay, that's right. You know? So is it a condition that interests you and so on? What about the literature? Well, the literature is, if you look and you phrase your literature searches properly, it will tell you what to research. So this is a paper that everyone's quoting at the minute in spines, a call for action, low back pain. It made it into the Lancet, and all they said was, we don't really know how to deal with back pain. And they wrote a paper and it got in the Lancet, and probably all these people have enormous, you know, fundings and all that sort of stuff, just to write a paper saying we don't know how to deal with back pain. And so if you look in the literature, and I don't mean search for a specific paper, I mean literally flick through the magazines, almost, you know, or the web pages, they will tell you what to research. So this paper came with a whole load of research questions that people are now going off and getting 7-figure grants for and stuff. So there's ideas in the literature if you're really brave and can't think of anything. Conferences. So we go to conferences to put lines on our CV, realistically, or to go and have jollies and nice dinners. That's the reality of it, certainly from a clinical perspective. But actually, the real useful one is listening to the debates and looking at the flavors of research that's going on at the moment. So, you know, in spines, it's all about navigation and computer and technology. That's what people want to read about at the minute. So if you want to make a success of it over the next couple of years in spines, write something about technology, write something about computers and robots and all this stuff. Now, they don't make any difference at all, but it's kind of the hot topic. Yeah. So if you're being an influencer, you need to do those. And that's where the conferences come in. Okay. The other side is that debate that we talked about earlier. So there's questions and answers after every group of abstract presentations or after every symposium and so on, right? Write those down. Those are the topics that are unanswered. They might as well be standing there and saying, here are the questions that we need to answer. Bang. Okay, pick one and run with it if it buzzes you. Okay. Meetings and symposiums like this, you know, maybe we'll talk about, oh, you know, I don't know the answer to this, or I don't know that, or we've got kind of cross-pollination of ideas. And increasingly, if we want to meet some of the objectives that you talked about, it's going to be sitting in the room and talking about what we're doing and working out in our symposiums, in our meetings, where the gaps in our knowledge are. And if we can each do a brick of that wall, suddenly we're going to rule the world with muscular people research. National bodies run a list, don't they, of, you know, outstanding research questions that need answering. You know, NIHR being the obvious example. You know, every week or 10 days or something, they publish a newsletter or a funding opportunities email. So it gives you a list of, these are the questions that need answering. These are the ones we're going to hand over a buttload of cash to you to answer. find one that you like and run with it. That makes it sound way easier than it is. But those questions are there and being written by people whose job it is to think of them and then advertise for people to do them. So they're there. And every tiny little fragment of healthcare has its own national body. There will be somewhere a society of occupational therapists for left-handed, one-armed chimpanzees or something, and they will have a list somewhere of questions that need answering. The hot topics, so there are, of course, as I say, there are these trends in healthcare, aren't there? Hot topics, COVID being a great example now. Anything to do with COVID, you're onto a winner sort of thing. Okay, there was a paper in Orthopedics and Trauma just this morning about how COVID's influenced spine surgery. It's meaningless, but it's the trend that it's going in. If you want to create output, you want to bring in resource to build your research kind of programs, you need to be on those hot topics. And then, of course, patients. So patients will come in and the questions they ask you are the research we need to do. So if they say, well, how long is it going to take you to recover from my hip replacement? And you can't say, it will take you 6 weeks, 8 weeks, whatever, until you can get to this level of function. It's because we don't know. Okay, or we don't know how to incorporate all the different factors for that particular patient. So ultimately, it all comes down to that, doesn't it? Because that's what all this research stuff is going to influence: patients' outcome, patients' care, and so on. And we mustn't lose sight of that. So the questions the patients ask you, if you can't answer it, and everybody else in your clinic can't answer it, it's because there's no answer. And the solution to finding new answers is doing research. So the Florida Gulf Coast University, which I'm sure is an excellent institution, runs, if you search for setting up clinical research ideas, this is what they come up with, and it's gloriously gobbledygook, but I've tried to turn it into English. And so they've tried to say, pick up 1 or 2 specific topics of interest in your discipline, and this is sort of constructing and refining your idea. Find a disease or condition that interests you through friends, family, or personal experience. Okay, a particular health issue that interests you and made you want to do healthcare in the first place. There was a reason we all did it. For me, my main goal, sadly. But for everybody else, there'll be a reason why you chose to do healthcare, right? So pick that and run with it, because that's when you're sat, at 8 o'clock on a Friday night writing a grant application, that's the only thing that's going to really motivate you to carry on. Recent news articles and health issues, go minuses and American, so that's where the money sort of flows through. Topics covered in textbooks, and your textbooks will have big gaps in them, or they'll say it is unknown X and Y. Is there a particular problem with healthcare management? So systems delivery is another area you can research. You have to be disease and health and how you get from one to the other. But how do the systems that provide for that function? So it's a whole separate world, unless you're in management. It's kind of outside our remit, if you like. You can combine interests. So, if you particularly love lungs and feet or something, there'll be some way of crossing those two together, okay, in a novel way that brings more information and usefulness to patients. And controversial issues, again, COVID is a great example, isn't it? I mean, again, this morning they've said that England did really badly, but also really well. And somehow that's a useful report. But controversial issues are another source of research ideas, right? So there's, I'm talking a lot, aren't I? Because there's loads of different ways of doing it. So once you go, well, actually, do you know what? I really do love lungs and feet. I want to find a way of making those work together. I'm deliberately choosing very disparate ones so as not to alienate anybody in the room, okay? So you need to evolve your idea, okay? And you need an idea that's specific enough that it's realistically answerable, but not so specific that you're never going to reach the answer, okay? So if you said, and these are deliberately crazy ideas, if you said, well, my life's purpose is to understand the role of medical cannabis for cats with glaucoma, we're never going to answer that. That's ridiculous. You'll be lucky if you even get someone to supervise it or fund it or anything. But if you do, how are you ever going to answer that question? Can't interview cats. You can't. How many cats are good? I don't know. Okay, but that's the point. So you see some research projects come, or some people turn up and say, I just love cats and cats with glaucoma, and I really want to understand how cannabis helps them. You need to sort of open that up a little bit to a wider project that's meaningful, but not so wide as something like saying, well, I want to research cancer. Well, that's great. People have to do that, but that's too broad. So you can't go too small because you'll never answer it. You can't go so broad that you're lost in this mire of information and direction, which I've got to say, in my experience, is where people more commonly hit this than they do this. More people will turn up and say, I want to do research in orthopedic surgery, than will come and say, I want to do research on the strength of the distal locking bolt in a PFN nail in a small group of people. And this is really the crux of setting the question. You have to invest effort in setting the question. And sometimes it will take weeks or months to do that, to know exactly what you're going to research and what your motivation for doing that is, because it's a long slog. And you need to refine that down. So something like psychiatric needs for the elderly following the COVID pandemic is an example of a reasonably answerable question, isn't it? You know, it's not a weird population like cats with glaucoma. It's a fairly specific situation, the COVID pandemic, as opposed to something broad like cancer. And, you know, that's the beginnings of a refined question, isn't it? It doesn't really say, well, I'm going to answer X or Y, but it pushes us in a direction that's practical and useful. So as I say, evolving the research question takes time. It is never effort that's wasted. So really thinking and spending time evolving it, talking to experienced researchers, different members of the team and so on to really narrow it down is useful. You start off by keeping it broad and then you slowly narrow it down in an informed way through discussion, through reading the literature, through understanding how we've got to the level of knowledge we already have. So you're standing on the shoulders rather than doing the same thing again. Okay, and the general rule is if you know a subject broadly, if you haven't heard of a paper, it's not worth it. Do you see what I mean? So you don't need to go and do a really in-depth literature review just to make sure someone hasn't answered your question. Because if your wider colleagues don't know the answer, no one's done it. Full stop. I mean, yeah, you can probably find a paper in the Thai Journal of Physiotherapy or something, which I have done in the past. But you know, if the answer's not on the tips of people's tongues, the answer's not there. Okay, so you narrow it down through discussion more than, I would say, looking at the literature and so on. Having a mentor is useful. Bear in mind this is for the foundation, as I know you're all pretty experienced researchers. Having a mentor for research is really useful. So you'll sit with them. They haven't been through the process of setting up their own research projects, doing the early steps and so on, and talking through those with them is a useful thing to do. They'll steer you away from fruitless avenues of refining your question and more towards a useful set of resources that can help you do that. And sometimes just freestyling ideas with them is useful. That's usually what I do. No one knows anything about spines, there's nothing to know. So the last thing I'll keep emphasizing is there's no rush to refine your research question. You just can't rush it. The more time you spend over it, the easier your project, whatever scale that is, will be at the end. If you just go, oh, new cancer in cats with glaucoma, then you'll regret rushing into that because you'll paint yourself into a corner further down the line. So you mustn't rush it. Take your time and talk with lots of people about refining your ideas. So then, if this is a research topic or a destination for your research or the region in which you want to create these new bits of information that can be useful for those patients, you need to take that idea, I want to research psychiatric needs of elderly in the post-COVID world, narrow it down into actually a question you can have an answer to. So, what is the requirement for antidepressants in patients aged over 65 in following the COVID pandemic? And there's an answer to that question, isn't there? If you just say psychiatric needs of elderly post-COVID, there's no question there to answer. And you need that question because that's ultimately your product of research, isn't it? It's the answer to that question. That's what research is, creating new knowledge. If you want to just describe the state of the art, that's not research, is it? That's a review or a systematic review or a policy statement or a protocol or something. To find new information, you need to answer a question. Okay? And you can only answer a question with an experiment. And I don't necessarily mean in a lab with little pipettes and those little lab monkeys that work across the yard there. An experiment can be exactly what we all do, clinical research, doing different things to different patients to as close a group as you possibly can to find out which is better, okay? And it can be an intervention that's what your experiment is, or it can be a measure that's what your experiment is, depending on whether you're doing a prospective or retrospective or observational study. So one way to refine the question or to create the question is using this thing FINER, which I'd never heard of, but seems to work very well. Okay, this is a fine inside of an aeroplane, which is the only useful picture I could find that describes it. So this is what you want your question to be. Okay, it's got to be feasible. You've got to actually be able to do it. There's no good, doing something that requires you to go to the space station or something, because it's not feasible to do. It has to be interesting. We all know people who've signed up to masters and PhDs and haven't seen it through because it just wasn't interesting enough for them, and it didn't have longevity. There's no point, absolutely no point, however great a study you've got planned, doing it is not interesting for you, or you think you're going to get bored of it in a year or two. It has to be interesting. What's more, it has to be interesting to the wider sort of industry, if you like. Just because you're into cats with glaucoma doesn't mean everybody else is. No one's going to read it if pointless doing it. My air ambulance MD was great for me, but actually no one wanted to read it. As far as I know, no one ever has. Okay, and that's my mistake. It has to be interesting for everybody else. It has to be novel. If it's already been done, it's pointless. Okay, and that's a little bit of caution now when you do systematic reviews and so on. It's a lot of work, and unless it's going to improve the understanding or the applicability of the existing knowledge, it's not worth doing it. Doing it for doing its sake is a lot of work. But novel data or a novel approach is always going to win. It has to be ethical, of course. We'll talk about ethics further along in the course, but basically don't mean. And it has to be relevant. So it's no good, working, say, here on a population based somewhere in, the Far East or something where things are very different. So it has to be relevant to where you are and what you're going to do. Okay. And fill the gaps in the knowledge. Like I say, it's got to be novel, it's got to be new, it's got to fill gaps. Otherwise, it's not research; it's something else, and you can leave that to other people. Okay, so what about, there's a couple of things I wanted to raise. What about feasibility? Okay, so how do you know that your idea or your research plan is doable? Well, these are a few things I could think of that would make me, that I might ask or I might think about when I'm building a research project to know whether it's even achievable, right? Because ultimately we have these great ideas and someone always says no, right? Computer says no. So pilot studies, so doing a mini version of what you're doing, okay, to a small group. For example, you want to do your research on hip replacements across London, whatever your study might be, maybe you do it just at patients at Newham, a small group in a controlled environment to see if it works, to see if that question is answerable. You could speak to the methodologists and the geeks behind the scene that are going to crunch your numbers for you, okay? Speak to the statistician. How many people do we need? If they say we need 1 million patients, well, it's not feasible, is it? If they say you need 5, you've got something wrong. No study has 5. Speak to the methodologists, the people who are real experts at designing studies. And that, interestingly, the methodology is what's going to get you your grants. The actual interest of the question, yeah, they look at it, but how deliverable is it? And then what the methodologists think is what's going to get the NIH to give you money. What about the trial teams? Now, I find trial teams really confusing because there's a clinical research network here and there and somewhere else, and then a hospital will have one and the university will have one and so on. I've yet to find a quick way around navigating all of that beyond just Googling BARS research people and seeing what comes up. Okay? Some of you guys will be way more familiar than I am. But there's sort of there's international groups, national groups, regional groups, NHS groups, and then university groups. And it's worth speaking to all of them because they'll have different balances of expertise and so on. Around here, I managed to find about the NIHR Clinical Research Network, so there's one for South London. And then there's a study support service as well within the NIHR Clinical Research Network who seem to, for free, tell you how to run your study. Not sure. It kind of sounds too good to be true. That probably is. But they seem to be useful people to know. Okay? The NIH,
You mean RDS?
that's what they say.
Yeah.
Study support service within the NIH. I mean, this
and we're North Thames CRM here.
There you go. So the line goes straight through, essentially here, as far as I can tell. And this is what I mean. It's all over the place. Do you see what I mean? So you need to spend time working on these ideas and these questions, okay, and speaking to people who actually have no business sitting in the foundation research. Okay. So then within the trust, so this, as far as I can tell, and bear in mind I haven't been in the trust very long, this is where the vast NHS clinical research support lies in this clinical research facilities at the JRMO, and there's people in there that seem to do kind of cover everything and can help you out there. And then the university will have departments. The university orthopedic department is, as far as I can tell, me every day, Xavier, once or twice a week and not on a Tuesday, and that's it. But outside of orthopedics, there will be much more developed departments that can be much more helpful than we can. So what about setting a question? As I say, this is the most important step, okay? So if the foundation guys were here, I would say to them, well, look, write down your research question and construct a research question. Now, there aren't any of them here, so we'll breeze through it. But essentially, constructing your question is about creating and refining this research question that we talked about the whole way through. And we use this PICO or PICOT system to try and develop it. So P talks about the population. So who are you studying? Which group of people? And people are so diverse that what applies to one group won't apply to everybody, and they apply to nobody else. So you need to think very carefully about who you're researching and why. And as a general rule, the more people you can include in a study, the better your study is, because the more of the population it can apply to. So if you limit it to, say, males aged under 10, your research really can only apply to males aged under 10 that are represented by that cohort. So let's say, for example, you do it in a place that has a single ethnicity for 99% of the people, and they're all male aged under 10, well, then your work only applies to a very small proportion of the population. But let's say you included, well, every human in London, you're covering absolutely every bit of the population and so on. And so you can generalize that probably to pretty much the whole world, I would think, with the diversity across the city. So choosing your population is really key. And what the journals and what the funders and what is good for humanity is as big a population as possible. And that has some practical limitations, doesn't it? We can't realistically do a project that covers everybody in London. It's just, whatever it's millions and 8 million people or something, it's not practical to do. So if you start making choices, you need to think about how your choices come together to make sure you're not under or over representing a certain section of our potential patient group. Does that make sense? Does that make sense, Toby? Yeah. Okay. So you have to think about your population, who you're targeting, and really why are you targeting them. It's no good doing a study on hip arthritis on, say, people in their 20s, because the incidence will be very low. Okay, but it's no good doing something about, I don't know, industrial hand and wrist accidents on people aged over 70, because the chances are that they're much less likely to be working. So choosing your population is key. So I is the intervention. So what are you changing about that patient's care that you're going to study? And sometimes that's really obvious. We're going to do an operation to fix their ankle fracture, or we're not. Sometimes it's much more subtle. Some of the non-operative interventions can be very difficult to describe in a closed manner, can't they? So, one person's quadriceps strengthening exercises will be different to another therapist, and so on. So describing those interventions is key. But again, you want to describe it as neatly as possible, but also so it can be applied as widely as possible. If you're a particular, say, specialist knee physiotherapist, and that's what you do, and you have a really in-depth understanding, it is no good creating an intervention that only you and your small group of expert knee therapists can do. It has to be applicable to as many people as possible, right? So that's what we try and do in musculoskeletal, because we represent such a huge chunk of ill health or poor health, is try and create these interventions that anyone can do. Okay, again, spine is a bit of a niche when it comes to that, but think about those trials you've seen in fracture or rehab or arthroplasty, where every other hospital will do it. Those interventions are really broad. Okay, so keeping it broad is the idea with intervention. So C is the comparator. So what are you going to compare that intervention against? And this goes down to the research kind of study design, ultimately, doesn't it? The best research compares an intervention with the existing best intervention. Okay, think about 2 tablets for hypertension. It's no good saying, well, is this tablet better than nothing for hypertension? Because unless it actively is killing people, yes, it's going to be better, right? Okay, but if you compare against the existing best, that's really what you want to know, isn't it? So when you're designing your study, your comparator has to be the existing best treatment. Now, whether that is set by kind of consensus amongst all those people you spoke to earlier, said, well, really, the best we know is physical therapy for an ankle fracture, or whether that's from the existing literature, or whether that's from national standards and so on. You just need to decide what is the kind of current gold standard, what's the current best treatment, and that's what you're going to compare intervention to. Anything else is pointless. Placebo trials and all that sort of stuff. Is anybody treated really with placebo? No, unless it's a brand new treatment for a brand new thing. A good example being like Dex for COVID. We didn't have any treatment, then we have Dex. Well, then you can compare with a placebo, fine. Which is mental because they're all in intensive care and asleep. How do they know they're getting? I don't know. So O. So O is for outcomes. So how are you going to measure which of these treatments is best? And there is a squillion ways of doing that. Okay, you can ask the patient, well, what do you think is best? Okay, you can ask your sort of colleagues and the rest of the multidisciplinary team, what did you think was best? How are you going to grade that? What I think is best will be different to what you think is best, and so on. And there's loads of ways of doing that we're familiar with, right? Scores, patient-reported outcomes, reported outcomes, right? Thousands of them. The reality is only 4 or 5 really good. Okay, if you want to go down in history, you invent an outcome score, you publish it, and you hope people use it. That's why there's so many. But deciding how you're going to measure whether one is better than the other is an important early step in refining your question. And if you don't know or you're not sure, then stop and spend time thinking about it. When I did my MD, it was who died. That's pretty easy, right? You're either dead or alive. So, do helicopters stop people dying or not when they've had major trauma? That's the question I asked. The answer is, don't really know. Okay, probably not. Probably not. There you go. That shows how poor a thesis it was, doesn't it? But deciding your outcomes early on will help you decide who you're going to involve in the study and how you're going to apply your intervention and what the comparator will be. Because if you want to compare your 2 hypertension drugs, but your outcome's going to be, well, whose fingernails fall off as a side effect, well, it's a different set of outcomes and maybe a different study design to actually all their resting blood pressure, over a period of 6 weeks. Do you see what I mean? I'm deliberately going crazy with the outcomes there. But it's really important to think your way through the whole study to help refine your question. And don't be disappointed if you have to go back. T, is about the kind of trial design, really. So is this going to be like a randomized controlled trial where you're picking 2 groups and you're doing something different to each and then comparing them? Or are you going to look back and see how one group was exposed and one wasn't and compare their outcomes and so on? So it does have a role in influencing your outcomes and your comparators and so on, but it's in the brackets because it kind of is separate, if you like. It comes into trial design rather than necessarily part of the question. But if you've got your population, you decided what you're going to change for that population one way or another, decided what you're going to compare that with and how you're going to measure which is better, then you've refined your question. Okay, but getting to that stage is way more than half an hour to do it. So that's it. That is how I think of research questions and so on. That's how I refine the research questions, and that's how I construct the research question. Any question? We've gone quickly because I had factored in a good 15 minutes to actually write a research question. But there's really no point doing that for you because you've done it 100 times. That's it.
Thank you.
Thanks, guys, online.
Thank you.
I don't know. And they're gone.
Thanks very much.
No worries.
Joey, thanks.